All right, I know that we are all ready. Everyone is going to be paying attention, right, Danny? Did you find it? Okay. All right, so you ready? You ready?
Yes.
Okay. All right. Class.
Yes.
Okay, thank you. All right, so property is definite integral. So on this one right here, it's a lot of stuff that we've actually already done, but now we're actually going to apply it in a different manner. So right here, let's see. Properties 1 through 4 in the section require function to be integratable. So that means I must be able to take an integration of that. Now, along with that, did I give you guys the...
Reference sheet?
Yes. Did I?
Yeah.
Okay, I did, right? Okay, good. So you guys do have that, and that's going to make your life so much easier. All right. Guarantee f is a function of integratable function that is continuous on a closed interval from a to b is integratable from a to b. Function that is bounded on a closed interval from a to b and at most has a finite number of discontinuities is integratable over a and b. Okay. So what we're doing is we're actually the sum of two functions. So it's kind of like when we had the derivatives, we would take the derivative of each term. It's kind of like if I had the derivative of 3x squared plus 2x, you would take the derivative of each term, right? Yes? Same thing goes with integration. So we are just going to take the integration of each term individually and over the same bounds. No. Where's my undo? There we go. Okay. So if I have two things like this, I'm just going to integrate each one individually because sometimes I need to do that because my integration is going to change. Remember when we were talking about that sine wave? We had a positive part and we had a negative part, but if we were trying to find all the area under the curve, we would actually have to find and actually turn it because one is counted as negative. So all the area itself needs to be accounted for. So anyway, the integral of the sum equals the sum of the integrals. So basically, we're breaking it up into two separate. Okay, so I could use this property right here. So I have this and this. Both of them, I'm going to take an integration of either. So from this one, x squared, what's the integration of x squared?
Oh, integration.
Integration, remember, not derivative. Over 3, very good. And then I'm going to do the same thing for the other one. Minus, okay, e to the x, right? Just like the derivative of e to the x is e to the x, integration of e to the x is e to the x. There we go. And my bounds are from 0 to 1. So go ahead, plug this in. Plug in the top. That's going to give me 1/3 minus e to the first. Now I'm going to subtract the lower bound. So I always try to actually do it like this. So I put a parentheses or a bracket to separate it right here. So there is going to be a distribution when I actually do the second part. So now plug in the 0. That's going to be 0 over 3 minus e to the 0. Yes? No? Maybe? Possibly? Possibly. Am I making sense or am I making nonsense? You aight? You're shaking your head because I'm staring at you? Are you okay with what I did? Are you okay with my x cubed over 3? Oh, okay, so I'm going to take this. So take the derivative of this. What would you do if you're going to take the derivative? So 3 out front, right? Okay, so that's going to give me 3. And what happens to my x? What happens to my x cubed? It goes to squared, right? But this one's still over 3, isn't it? And so what happens here? Yes. So what this is we're taking the antiderivative. So the antiderivative is integration. So the rules are backwards on this one. So to take the derivative, I do these steps right here, right? Antiderivative, I add 1 to my exponent and then divide by the exponent. Make sense now? Okay, good. All right, so where are we at right here? So this is going to be 1/3 minus e to the first. And this is now going to be, what is 0 divided by 3? 0. What is e to the 0? 1. But it says minus 1, so this is now going to become plus 1. So it's going to be, so minus 0 plus 1, just to show that I'm distributing both of those right there, okay? So that means that my answer is going to give me 4/3 minus e to the first. Sound good? Integral of a constant times a function. We could actually factor a constant out to make my integration easier. So if there is a common factor in it, I'm going to pull it out to the front, and that's what this says. Is there a constant that I could factor out? What is it? Yeah, let's factor out a 3. So if I factor out a 3, then integration of from 1 to e and you guys remember from last week, what is the integration of 1 over x? How about this? Let's do the math. Let's rewrite it first of what it would look like. As an exponent, wouldn't that be x to the -1, right? That would be x to the -1, right? And so if I were to integrate that, what would I do? Add 1 to the exponent. So it'd be x to the 0, then do what? Divide by the exponent, which is 0. And we had this problem last week. And I said, hey, that one's a special thing. What was the special thing I came up with that? Denny? Yes, you do. Because you were here. I know you took these notes. Not those ones? So you didn't take it on the 5.3 notes? You don't remember doing that right there? You know what? Anyone could be looking at their notes too, right? Unless you already know it. What is it?
Get logged into this.
Slide number 7. What is it?
Is it absolute value?
Yes, ln absolute value x. There you go. Okay, so you did do it. We were doing it. Okay, you just need to, like, throw out some memes that are stuck in your head and, put some math back in there. So that's going to be ln, right? So it's now going to be ln of absolute value of x. So let's do my integration. 3 times the integration of ln absolute value x from 1 to e. All right, let's plug them in. So on the outside, I'm still going to leave that 3. ln of e. What is the ln of e?
First off,
Is it? Maybe. It's also in the flashcards. Not flashcards, but what was the thing I gave you? The reference sheet? Yep, it is. It's on page 4. Page 4 of the reference. So ln of e is going to give me 1. Ln of e gives me 1, so it's 1 minus my lower bound, which is ln of 1. What is the ln of 1?
0.
ln of 1 is 0. So this is going to give me 3 minus 0. Yes, no, maybe, possibly. Okay. All right. I'm going to take this one here. I'm going to rewrite it before we actually even try to do it. So right now, this would be, if I'm looking at it as a derivative, you would say this is a quotient rule, right? Say yes. But I could simplify this to make my life a whole lot easier, right? So by simplifying it, that means that if it's all over this, I'm going to divide it. So it's going to be 3x cubed over 2x minus 6x squared over 2x minus 5x over 2x plus 4 over 2x, and then bring down my dx, and it's my integral from 1 to 2. So by rewriting it and separating it as individual fractions, we can kind of make our life a whole lot easier here. All right, what's going to happen to our x's on this first term?
You're going to cancel.
Cancel, and I'm left with x squared, right? Over 2. So 3x squared over 2 minus
6 or 7.
3,
Oh, yes.
3x, okay, minus 5 over 2 plus
2 over x.
2 over x, and then bring down my dx, my integral from 1 to 2. All right, are we ready to integrate? Yes, we are. We now are ready to integrate. So I simplified a whole lot. So my integration is now going to be, mental math on this one. Remember, you're adding 1 and then dividing by that number. Over what? 6, right? But what about that 3 and the 6? Can I reduce that? Okay, so if I know that there is going to be a 3 here, could I just knock off the 3 that's over there? I can simplify as I go too, right? Okay. Just think about that when we do this, all right? Next one, so minus, this is going to be yep. Minus,
This is 5 over 2.
nope,
Well, there should be. Oh, no, you add 1 and 5x
yep,
over 2.
because you're adding the x value there, right?
Yeah.
Okay, you're adding the x value.
Well,
So,
multiply.
Denny, you ready?
The 2 squared over 2x.
Where's your x at? In the bottom.
So it means it's 2.
2. What's the integration if it's on the bottom?
Oh, ln x.
It's ln x. ln absolute value x. Okay, and that's going to be my bar from 1 to 2. So I'm going to clean this one up a little bit because why not? That's 1/2 over on that one. All right, so now let's evaluate it. So we're plugging in the 2. So 2 to the 3rd power is 2 times 2 is 4 times 2 again is 8 divided by 2, 4. Okay, next one. This is going to be 2 squared is 4 divided by 2 times the 3 out front. So minus 6. This one over here, plug in the 2. So there's 2 there over 2. What's going to happen? Cancel, and I'm left with just 5. So minus 5. And plus, this one you could just plug in as is, because this one is a positive number. So it is going to be that, so it's going to be plus 2 ln of 2. Now minus, I'm kind of running out of board here, minus my bottom bound, my lower bound, which would be the 1, right? So we're plugging in 1. So that's going to give me 1/2 minus 3 over 2 minus 5 over 2 and plus
0.
0. Very good, because ln1 is going to give me 0 times that 2 is going to go away. And I need some more board over here. So 4 minus 6 minus 5. And minus all of this, which was it like 1/2? 3/2? Minus 5/2? Plus 0? Yes? Okay, good. Alright, I got a whole bunch of fractions there, so let's actually just make common denominators there. Or, let's see, let's do a little bit of mental math right here. So take away one of those, so that's going to be minus 4 over 2, minus 7 over 2. Alright, let's make these all over 2's. So that would be, let's see, 8 over 2 minus 12 over 2 minus 10 over 2. So that's going to give me what? Negative 4, negative 14 over 2. And plus 2 ln of 2 minus negative 7 over 2. And distribute. Boop, boop. And that's going to give me a negative 7 over 2 plus 2 ln of 2. And feel free to check my work, because someone has to. You guys have your calculators, or? All right, so let's see, menu, calculus, integral from 1 to 2, and so let's go with the original problem.
Equation.
Okay, so 3x cubed, so
Control divide.
yeah, control divide, 3x cubed
Minus 6x squared. Minus 5x. Plus 4. Divided by 2x. Equal by the
And let's check my answer. What do I have? So it was
negative 14 over 2 plus
negative 7 over 2 plus 2 ln, which is 2.
you stupid.
Hmm?
Yeah.
So the calculator gave me what the approximate answer is, and I plugged in my answer and let it approximate also. And from there I'm like, okay, got it right. So that's a good way to check your answer all the time. All right, before we actually doing some of these, I'm gonna save this for later. we're gonna pick this up on Wednesday.
Yeah,
Tomorrow's an I day.
Friday's an I day, so it's only Wednesday and Thursday we have.
Yeah, so we'll cover this then. So make sure you all like, share, and subscribe.